Hello everybody, Godzilla Freak here, Andrew in the back, and welcome to another school project for Andrew. I know, kind of boring, but they're doing sky science, so it's fun. Yeah, it's gonna be fun. Unless you are blind, you would know that this is about how stars form and sustain themselves. I literally just repeated the title, so if this was a surprise then you are actually blind. Andrew did the research. I'm just setting up a robot. He also edited the project. So you could say it's his, especially when the other kids get parents. A god is a little more overpowered, but I don't do too much. Please don't count me as help. I just want the credit. As for the project, let's get started. Starting off, I will give a very basic explanation. Stars can form when interstellar gas and dust go into dense concentrations and form molecular clouds. Molecular clouds are only 10 to 20 Kelvin, which is incredibly good. At this temperature, atoms bind together and gases become molecular clouds. The most common molecules are CO and H2, these interstellar gas clouds. The cold also forces the gas to go in high densities. They form stars at a certain point. The star formation begins when denser parts of the cloud collapses under its own gravity. These cores have the mass of about 104 solar masses. The cores of the clouds have more mass than the outside, so they would collapse first. The fragments that break off clump into volumes 10 to 50 solar masses. These clumps then split off again to make protostars. The entire process in its entirety takes about 10 million years. To put it into human words, it's kind of hard actually. I already had to turn it into English. Cut me some slack. PLZ. No. Basically, things in space become cold and then condense in order to form stars. 10 to 20 Kelvin is just above absolute zero, about -263, -253 degrees Celsius. The density of these gas clouds that are formed are so tightly packed they fall apart onto each other. These clouds are about 10,000 times the mass of our Sun. The centers have the most mass, so they fall apart first. The pieces that fall off clump up into more clouds, usually ranging from 10 to 50 times the mass of our Sun. These clumps then split off to create baby stars. The process takes about 10 million years from start to end. True stars are formed when protostars exceed 10 million degrees Kelvin. Kelvin is a system based off of Celsius increments starting from absolute zero instead of zero. At 10 million degrees Kelvin, hydrogen fusion can start, therefore powering the star. The Sun and other stars sustain themselves by using a process known as nuclear fusion. The stars can take hydrogen atoms and fuse them together with their high temperatures. When hydrogen atoms fuse, they release a large amount of energy. This is because of the famous equation E equals mc squared. Of course, Einstein did not invent this phenomenon, but he did, in fact, discover it. What this equation means is that energy and mass are two of the same. Simply rearranging the equation goes into E divided by c squared equals mass. C stands for the speed of light. C squared is a very large number. What this means is that a very small amount of mass can transfer into a very large amount of energy. When fusion occurs, because of this equation, a very small amount of mass can be used to create a very large amount of energy. Because hydrogen has a positive charge, it also takes a lot of heat to fuse in the first place, which is why true stars form at such a high temperatures. The most basic form of fusion is from H1 atoms to He4 atoms. The reason stars glow is because photons, light particles, are also released during this process. Fusion can sustain stars for very long periods of time. Over time, the star creates more complex elements like carbon and aluminium. Iron is the last element a star can create on its own. As a star gets older, an iron core builds in the center of the star. Iron does not kill a star, but there is not a lot of profit and energy to be gained from it. When a star creates too much of an iron core, the star will no longer have enough useful energy and end up collapsing. As a star similar to our own dies, it will start to contract, but heat up the outer layers. The heat on the outer layers then expand to a point. The radius will increase into a red giant. If this happens to our sun, it will expand all the way past the entirety of Earth and a little more, meaning we would be inside of the sun at that point. The sun will still be hot enough to fuse some helium into carbon. Past that point, the core will begin to cool. The outside layers will be ejected out, then collect around the dying star to form a planetary nebula. The star will cool into a white dwarf, and later go into a black dwarf. What I mentioned earlier with the iron mainly affects stars larger than our sun. When that happens, the star will go supernova, releasing enormous amounts of energy into the atmosphere and form interstellar clouds to form more stars. A smaller large star will turn into a neutron star. When the larger one collapses into a black hole, someone else is already doing black holes. That's the end of video, guys. Hope you enjoyed and learned a little bit about stars. Thanks for watching.